Find the area of red equilateral triangle. Line and triangle constructions, Pythagoras theorem, cosine rule, knowledge of quadratic equation, area formula of a triangle involving sine of angle are used to solve this question. Solution. Label points G, Q, C, D, E, K, J, H, and L. Where O and J are the centers of the larger and smaller circles, respectively. Where the smaller circle is tilts at an unknown angle with a diameter of K, L. The larger circle is horizontally placed with diameter of G, Q, which equals to 16 units. This implies that its radius equals O, Q, which equals to OG. This result is equals to 8 units. Also, join line O, L and line O, C. Each equals the radius, R, of the larger circle. Line O, C is an angular bisector of angle D, C, substitute the value of the square that it is a perpendicular line, and we have the line bisector of line KOL. Since GQ equals 2 times R, the diameter of the larger circle, it follows that line OG equals line OQ, which equals to half of line GQ. The result is equals to 8 units, as shown on the screen. Let line CJ be equals to X, which is the height of the red equilateral triangle. Since O is the center of the larger circle, where OC and OL equals 8 units. It signify that line OJ equals line OC minus line CJ, which equals to 8 minus X. By Pythagoras theorem, the square of LJ equals the square of line OL minus the square of line OJ. Substitute values and we have that the square of line LJ equals the square of 8 minus the square of 8 minus X. Expand bracket and combine like terms. Then, simplify so that the square of line LJ equals 16 times X minus the square of X, as shown on the screen. Take the square root of the equation. Hence, the line LJ equals the square root of 16 times X minus the square of X. We know that line LJ is the radius of the smaller circle, which equals to line KL. Label point P and join line OP. Since line LJ equals line PJ, it implies that line OP equals line JP minus line JO. Substitute values and we have that. Line O, P equals line J, P minus line O, J, which equals to the square root of 16 times x minus the square of x minus 8 minus x. It implies that line O, P equals the square root of 16 times x minus the square of x minus 8 minus x. Also, label point T and join line T, C. Where line T, C is part of the radius of the small circle, with radius J, T. Where J, T equals the sum of J, C, and T, C. Line OT equals the square root of 16 times x minus the square of x plus 8 minus x. Label points R and M. Join line PUM and line RT. Assign angle θ to points T and M, respectively. It is because angles in the same segment are equal. From triangle P, OM. Use sine rule. Line OP divided by sine θ equals line OM divided by sine 180 degrees minus the sum of θ and alpha. Observe the diagram carefully and know why. Triangle P, O, M is similar to triangle R, O, T. Substitute values and we have that. The square root of 16 times x minus the square of x minus 8 minus x, all divided by sine θ, equals. For divided by sine 180 degrees minus, in bracket, the sum of θ and alpha. We call it equation 1. In the left-hand side, shows the values we obtained earlier. From triangular ROT. Use sine rule. Line O are divided by sine θ equals line OT divided by sine 180 degrees minus the sum of θ and alpha. Substitute values and we have that. 6 divided by sine θ equals the square root of 16 times x minus the square of x plus 8 minus x. All divided by sine 180 degrees minus the sum of θ and alpha. We call it equation 2. Cross-multiply each of equation 1 and equation 2. Isolate the ratio of sine of angles in one side of the equation. Equate the results of equation 1 and equation 2. We have that. The square root of 16 times x minus the square of x minus 8 minus x. All divided by 4. Equals. 6 divided by the square root of 16 times x minus the square of x plus 8 minus x. Cross-multiply. The square of the square root of 16 times x minus the square of x minus the square of 8 minus x equals 6 times 4, which equals to 24. Simplify to results shown on the screen. Expand bracket. We have that 16 times x minus the square of x minus, in bracket, 64 minus 16 times x plus the square of x equals 24. Open bracket. You should recognize that the knowledge of arithmetic and algebraic simplification and operations are required at this point. Combine like terms in one side of the equation and simplify. We have 16 times x minus 2 times the square of x minus 64 minus 24 equals to 0. Remember that the constant term of the equation is negative 64 minus 24, which equals to negative 88. Divide the equation by 2 and we have that 16 times x minus the square of x minus 44 equals 0. Rearrange terms again in the other side of the equation to remove the negative sign in square x. Our new equation becomes square x minus 16 times x plus 44 equals to 0. Using the general quadratic formula, which I believe you know, that is, x equals negative b plus or minus the square root of square b minus 4 times the product of a and c, all divided by 2 times a, where a equals 1, b equals negative 16 and c equals to 44. Substitute in the formula. X equals 16 plus or minus the square root of 16 squared minus 4 times the product 1 and 44. All divided by 2 times 1. Simplify and we have that x equals 8 plus or minus 2 times the square root of 5. However, x is not equals to the sum of 8 and 2 times the square root of 5 in units, since x is less than line OC, which is the radius r of the larger circle. X is equals to the height of the red equilateral triangle. We will now focus our attention on the red triangle since we have gotten its height and it is an equilateral triangle. Let line CE be equals to y, which is the side length of the equilateral triangle, DCE. It follows that line JOE equals half of y, which equals to half of line DE. That is equals to line DJ. By Pythagoras' theorem, the square of y equals the sum of the square of x and the square of half of y. Substitute values and rearrange terms of the equation. We obtained a new equation as shown on the screen. Simplify this equation so that 1/4 of 3 times the square of y equals 64 minus 32 times the square root of 5 plus 20, which equals to 84 minus 32 times the square root of 5. Cross-multiply and solve for the square of y. Now, let us proceed to find the area of the red equilateral triangle. Since we have obtained the product of its side lengths, the square of y, and we know the properties of equilateral triangle. It implies that the square of y equals the product of 4 and 84 minus 32 times the square root of 5, all divided by 3. Hence, area of the red equilateral triangle equals half the product of line CE and line CD times sine 60 degrees, which equals half the product of the square of y and sine 60 degrees. We can now substitute the value of the square of y we obtained earlier. We have that the area of the red equilateral triangle equals the product of the square root of 3 and 84 minus 32 times the square root of 5, all divided by 3, in square units. After simplification of substituted value. Therefore, the area of the red equilateral triangle equals the product of the square root of 3 and 84 minus 32 times the square root of 5, all divided by 3 in square units, or 7.19 square units, to 2 decimal places.